Okay, so we'll start with a discussion of paper 6, unit 6. This is October 2021 paper, and we did first two questions. So today we'll do question 3. A student investigated the standing waves using an apparatus as shown. So there's a microphone in the bottle and a signal generator. So what will happen? This signal generator will produce a waves. So the wave will travel and then it bounce back. So when the two progressive wave traveling in opposite direction, they give rise to a standing wave. Some region they increase the effect of each other, we call antinode, and some region they cancel out the effect of each other, we call nodes. That was there in AS physics. The signal generator was adjusted until a loud sound was heard and known as a resonant frequency. Describe how student used the oscilloscope to identify the resonant frequency and determine its value. What is the meaning of a resonant frequency? Resonant frequency means it's a frequency at which the amplitude of a vibration is maximum. That's called a resonant frequency. So how student can determine, and this is a time scale is there. Like this one is a time scale. Okay. So how student will determine the resonant frequency? First, student will find the wave pattern which gives maximum amplitude. Because a wave pattern which gives the maximum amplitude, that wave pattern, that is a resonant frequency. That is we did in a simple harmonic motion. Simple harmonic motion, when we produce a wave and we force the object to vibrate and the object vibrate with a maximum amplitude, we call that frequency as a resonant frequency. So first, what students should do? Students should find a wave pattern which gives the maximum amplitude. That is the first thing. After finding the wave pattern which gives the maximum amplitude, then find how many peaks are covered. Find the number of the peaks in the pattern. Then find the distance between sorry, I was disconnected. Look, how student can determine the question was how student can find a resonant frequency. The resonant frequency means the frequency at which the amplitude of vibration is maximum. So first student will determine the wave pattern which gives the maximum amplitude. That is the first thing. So first we should find the wave pattern that gives the maximum amplitude. And after finding the wave pattern which gives the maximum amplitude, find the distance between two adjacent waves. Then like finding this distance between the two adjacent waves. Then multiply the number of the waves with the division, because each box stands for certain division. Like example, maybe one box stands for 30 millisecond, 20 millisecond, 50 millisecond. So multiply by the number of the waves with the division like of each box. Then this will give us a time period, because the distance between the two successive crest or two successive trough, that is distance is wavelength and the interval is a time period. So this will give us a time period. But if we need the frequency, what will the last step to get the frequency? So frequency will be reciprocal of the time period. So after finding the time period, we just take a reciprocal and we get the frequency. Is it clear? How we determine the frequency using a time period? The next question, the student reduces the volume of air inside a bottle by adding a known volume of a water. He record the following values of a resonant frequency for each value of a V, like the how much volume of a water is added in a resonant frequency, and plot a graph between log F and log V. So what you have to do, first you have to complete this. First you have to complete this for log F is there. So you can have this log B and then you can have this log F. Just take a log of these values and you will get the answer. And log of frequency, you'll get the answer. And use additional column and record the process data because you have to use log V and log F values here. And it is suggested that the relationship between F and V is given by F is equals to kV raised to power half, where K is a constant. Discuss whether the graph support this suggestion. What actually happened, like when you plot a graph here, according to this equation, if I take, like I have the F is equals to kV half, then if we take log both sides, so this will be equals to log F is equals to log kV raised to power minus half. Whenever in log the two quantities are multiplied, we write them in addition. So I can write log F is equals to log K plus log V raised to power half minus half. Then whenever any exponent or a power is there, we write as a coefficient. So we can say log F is equals to log K minus 1 by 2 log V. If I rearrange the equation, so it will be log F is equals to minus half log V plus log K. So when I compare with the equation of a straight line, which is y is equals to mx plus c. So on y-axis, if I have log f, so on y-axis, we'll have log f, like we plot a graph. And on x-axis, we plot log v. What should be our gradient? The gradient of this graph, when we plot the graph, if our gradient is minus 1 by 2, or if our gradient is equals to half, it means that this is consistent with the equation. And if your gradient is not half, means it is inconsistent with the equation. So you have to complete a table, then plot a graph between log f and log b, and then find the gradient, and your gradient should be equals to half. If your gradient is equals to half, it means it is consistent. If the gradient is not equals to half, so means it is not consistent with the result. Is it clear, this question? Next is question 4. We have an L-shaped steel rod which is held horizontally, as you can see here, and horizontally in a clamp stand by shorter end, as this shorter end is there in a clamp stand. The end of a steel rod is at a height P above the bench. The student attach a mass M to the end of a steel rod and that causes it to bend towards the bench. The end of a steel rod was then at a height Q. So this is at a height Q now. Describe two techniques you should use to determine P and Q. Like how she can determine P and Q accurately as possible. First thing, whenever we are measuring certain distances, so we should we can use a set square and ensure that the meter rule or the meter scale is exactly vertical and the ends are very close to each other and we should look perpendicular, like because we are measuring this height. So what this meter rule, the meter rule should be closer to this part. So how ensure that it is accurately as possible? So the meter rule should be closer to L-shaped rod, and we should look perpendicular and avoid a parallax error. The difference between P and Q was recorded, and the difference was 26 millimeter plus minus 1. Explain why the uncertainty in this value is given as 1 millimeter. Look, when we work out a difference between P and Q, like P minus Q, how P is measured? When we are measuring a P, so P is measured by using a meter rule or a meter scale is there. And so the uncertainty in each value, when we are using a meter rule or a meter scale, the uncertainty in each value, like example, so this is 0.5 millimeter and this is also 0.5 millimeter because we are measuring P and we are measuring Q. Whenever quantities are added, subtracted, the uncertainty always add. So uncertainty in measurement of a P is 0.5 millimeter and uncertainty in measurement of a Q is also 0.5 millimeter. So what will be the uncertainty in these two measurements? Because when we are working out the difference of 0.5 plus 0.5, that's why it is equals to 1 millimeter. So uncertainty of a single reading in the half resolution of a meter rule, like when we take a single reading and there's a half resolution, that is always 0.5. So you'll mention uncertainty 0.5 millimeter, and whenever two quantities are added or subtracted, uncertainty always add. That's why the total uncertainty will be 1 millimeter. Even if we were finding like P plus Q, if you were finding the uncertainty in P plus Q, that also it will be, because uncertainty in P is 1 millimeter, uncertainty in P is 0.5 millimeter, and uncertainties in Q is also 0.5 millimeter. So uncertainty always add, even we add the quantities or subtract the quantity. Multiplication, it will be multiplied by the factor, but in addition and subtraction, uncertainty always add. So even in addition of P and Q, that will also be 1 millimeter. Subtraction also 1 millimeter. The steel rod has a circular cross-sectional with a diameter approximately 2 millimeter. Most appropriate instrument should be used here. So whenever we are measuring a diameter, so in that case, a micrometer should be accurate. Why micrometer is accurate? Because the accuracy, so we'll one mark for mentioning a micrometer, and one mark is for percentage uncertainty. What will the percentage uncertainty? Percentage uncertainty is the uncertainty of a micrometer, which is 0.01 millimeter, divided by value recorded, which is 2 millimeter, multiplied by 100. So when we solve this, like it will be 1 divided about 0.2% will be there. Or 1 divided, about half will be there. Because the maximum value we are measuring, because this will be 1 divided by 2, so 0.5% uncertainty. So 0.5% uncertainty, that will be very small. And for a half range, it will give uncertainty of 0.25. But in this case, uncertainty will be 0. Because the uncertainty, the smallest value which a micrometer can record is 0.01. And the value which we recorded is 2. Into 100, so this will give us about 0.5%, which is a very small uncertainty. Explain one technique that she should use to measure D. So whenever we are using a micrometer, what we should do? We should measure the distance from different orientation and take an average. So repeat with different orientation, calculate an average, which will reduce the random error, or check for zero error to eliminate the systematic error. So whenever we repeat the experiment, we are reducing a random error. So change the orientation and repeat, take average. And that will reduce the random error. Or we can check for zero error. And when we check for zero, what will happen? It will reduce the systematic error. So random and systematic errors will be reduced if we are checking for, like, if error is there in a system, that will be systematic error. Like zero error is there, that is a systematic error. But if we repeat experiment, any random error can be eliminated. We have the result is there whenever you have a set of values. How we can work out it is we have to calculate the uncertainty. So how to take an average, and remember one thing, if one of the values is anomalous, you will not include in your calculation. So we have to calculate a mean and then it's uncertainty. How to calculate a mean? Just add them and divide it by the total. You'll get the mean. But how to get the uncertainty? The half range formula, it's a maximum minus minimum divided by 2. So maximum value in the combination, that is 2.73, 2.37, minus the minimum value in the combination is 2.33 and divided by 2. This is called a half range. So 0.04 divided by 2, 0.02 will be the uncertainty. So this will be 0.02 and the value, average value will be, add them and divided by 5. So this will be 2.35734. So this will be 2.35. That's how, so for a group data, if you want to work out the uncertainty, it's a maximum minus minimum divided by 2. But keep one thing in mind, if one of the values is anomalous, like that is not in the range. Say one of the value was 2.94. So we'll not include in calculation of the uncertainty as well as the average. We'll ignore that value. In that case, we'll take only the 4 values and then divide by 4. Shear modulus G is given by this equation. Determine the value of a G. So you just have to substitute the values here, like all the things are given. M is given as 100 gram, but if you want to, because if you want to convert, SI units are important. So converting to kilogram, millimeter is there, converting to meters, and then you will get the, just substitution is there, but this is in gram, converting to kilogram. This one is in centimeter, converting to meter. This one is in centimeter, converting to meter. This one is also in millimeter, converting to meter. And then D, the value of a D, that was here, mean value of a D, and that was in millimeter. Again, we'll convert into meter and we'll get the value for G. Because see, Newton per meter square. So the only thing what you have to do is a unit conversion and then substitute in the formula. In part D, the table gives the value of a G of different types of steels. Deduce whether the data provided in part C would allow the student to determine the type of a rod was made from. One is a structural steel, another one is a carbon steel. And these are the uncertainties. Look, what you have to do, you have to work out the percentage uncertainty in the value of a G, and you have to work out the percentage difference. If the percentage uncertainty is more than the percentage difference, means the two values are equal. But if the percentage difference is higher, then the two values are not equal. How to work out the percentage uncertainty in these values? And when you're working out the percentage uncertainty, unit conversion is not important, because when you have the percentages, even the data is in millimeter, meter, it does not make any difference. So unit conversion is not important. How we can work out the percentage difference? If I want to work out the percentage difference in the value of a G. So 32 is there, 32 is constant. So that does not make any effect. Pi is also constant, that does not. M is there, G is there. G is a value of a gravity, which is also a constant. So no need for that. So the uncertainty is due to M, L, X, and D. So what is the uncertainty in M? So to work out the uncertainty in, or starting with L, if we start with L, so this will be 0.1 divided by 58.9 multiplied by 100. But because, so L is there, so it's the same thing. Then what is the uncertainty in X? It will be 0.1 divided by 10.3 multiplied by 100. And but this is X square. So what will happen to the total uncertainty? It will be multiplied by 2 because it's X square. Then what about the uncertainty in Y? So it will be 1 divided by 26 into 100, but no multiplication factor. And what about uncertainty in D? So D we did, that was the uncertainty which we calculated in D in the previous part. That was 0.02 was there. Divided by value recorded, the value, the average value 2.35. So this was 0.02 divided by 2.35 into 100, and this whole factor will be multiplied because of power 4. So it will be multiplied by power 4. And then we'll get the uncertainty of each of them. Like we'll get the uncertainty in X square. This will be uncertainty in X square. This is uncertainty in Y. This is uncertainty in L. And this is uncertainty in D4. And we just add them, we get the percentage uncertainty, which will be about 9.4%. So we'll get the percentage uncertainty, which is a 9.4%. Then, like, this is about the percentage uncertainty. Second thing, you can calculate the percentage difference. Percentage difference is a maximum, how to work out the percentage difference? Maximum minus minimum divided by standard into 100, if we have the standard value. So percentage difference, or there's also another way to do this question. Like once you work out the percentage uncertainty, say your percentage uncertainty is 9.4%. So means your value can be 9.4% more, or your value can be 9.4% less. Like once you get the value of a G, that in the previous part, when we calculate the value of the G, example, the value of the G was 7.9 into 10 to the power 10. This was the value of a G. So because we worked out the percentage uncertainty is 9.4%, so means the percentage, and it can be plus 9.4%, the value, or it can be minus 9.4%, the total value. So just work out the maximum and the minimum, like you will get the range for value of a G, what could be the upper limit of G, and what could be the lower limit of a G. And after working out the upper and the lower limits, compare with these two values of the G. If the upper limit is higher, like example, once we work out the upper limit, say the upper limit is coming out 81, like the maximum value. So it will be difficult which steel is this, because it can be carbon steel, it can be structural steel as well. An example, if the lower limit, example 75. So the upper limit and lower limit both, because the question is deduce whether the data provided in part C would allow the student to determine which type of steel, like determine the type of steel rod was made from. If our higher limit, upper limit, and the lower limit, these two values are within that limit, it means we cannot determine, because the maximum value can be 81 and the minimum is 75, and both carbon steel and structural steel have this range, like can lie within this range. So it will be difficult to determine whether it is made up of structural or a carbon steel. But what if the limit was, like example, 80 was there, or say the limit was 78 was there, the higher limit, and then 76. So then we can determine, because in that only one type of steel is coming in that range. But now what happened? Two different types of steel, and our result shows that it can lie between any of them, like 81 to 75. So it might be carbon steel or structural steel. So we cannot determine which type of steel this rod is made of. Is it clear? The last question.